So the last topic of our today's lecture is standardization. Now, what do we mean by standardization? When we subtract the mean of a variable from each observation and divide that observation by the standard derivation of that variable, then what would happen is that that variable would be called a standardized variable. And once we standardize the variables, their interpretation wouldn't be in, say for example, millions or billions or number of years of education or rupees. Their interpretation would be in terms of standard deviation, because the denominator, we have divided all the variables by standard deviation of the variables. So the denominator is same, the standard is same. So now we would interpret them with respect to standard deviation. So just look at the formula. So this y-sqaure would be our new variable, and it would be yi minus the mean of the variable divided by the standard deviation, and similar would be the case for any x variable. So this y-sqaure is the standardized form of the yi variable, and when we standardize the variable, its mean would be 0 and its standard deviation would always be 1. So when variables weren't standardized in our previous example, this is how we interpreted it. Both the variables were in billions. We said if the GDP would increase by 1 billion, the GPDI would increase by 0.25 billion, right? So when the variables are standardized, what we did, we took the series of the GDP. This was our GDP, all the data, each observation. We calculated its mean, we calculated its standard deviation. Then what we did is we deducted mean from each observation. So if this observation was 5, so we deducted the mean from this 5. If this observation was 7, then we deducted the mean from this 7. Now we had a new series, and this series was xi minus x bar. We divided each observation by the standard deviation. So the result from this step was then divided by the standard deviation. So in case you have got the idea. So this is how we standardize the variable. So once they are standardized, we run the regression, we get this beta coefficient. And how would we interpret this? The interpretation would be in terms of standard deviation. So in this case, if the GDP increases by 1 standard deviation, now you have noticed that we are interpreting it in terms of standard deviation rather than in terms of their own units, the units that they initially had. For example, the GDP had the unit of billion dollars. So the interpretation would be, if GDP increases by 1 standard deviation, the GPDI would increase by 0.98 standard deviations. Right, so everything is in standard deviation. The advantage of this standardizations, we would have them when we discuss heteroscedasticity and other aspects. But one of the advantage is now, if instead of single independent variable, we had, say for example, we also had one more independent variable. So there was GDPI and say there was interest rate, right? So when the variables aren't standardized, we cannot compare their coefficient. We cannot say that this specific variable have more effect on the dependent variable as compared to the second independent variable. So in this case, if we had the second independent variable and its coefficient was 0.58, then we can clearly compare them. Obviously, the GDPI having a 0.9 standard deviation have higher an effect on GPDI as compared to the interest rate. So the advantage is that when all the variables are on same scale, they can be compared. One more thing you would have noticed is that we do not have the constant term, and the reason is that if you remember, the formula for constant term was y bar minus the slope coefficient into x bar. So now this y variable is standardized and this x variable is standardized. So remember when we standardized the variable in the previous slide, we just said that their mean would be 0. So if their mean is 0, this alpha would also be 0. So standardized variables do not have the intercept term. The intercept term is 0. And if the intercept term is 0, then you would have probably realized that it makes it the regression through origin. And in regression through origin, you must always remember that r-square becomes meaningless. So because in standardized variable the regression is regression through through origin, we wouldn't have the r-square, and even if the statistical package gives us the r-square, that r-square would not be meaningful.